Welcome to the Health AI Brief, breaking down the AI shaping our world one concept at a time. You've probably seen a paper like this where a headline is that a new AI model achieves a spectacular 99% accuracy on a diagnostic task. It seems like a huge breakthrough, but when another research group tries to use the same model on a new group of patients, that performance plummets. It's no better than a coin toss. What happened? This is the classic and perhaps most critical failure mode in machine learning. It's a problem called overfitting. And it's the difference between a model that's generally useful and one that's just a statistical party trick. The best way to think about overfitting is to imagine a medical student preparing for their final exams. The student doesn't try to understand the underlying principles of physiology or pathology. Instead, they get hold of the last 10 years worth of exam papers and memorise every single question and answer word for word. On exam day, if the questions are identical to the past papers, they'll get a perfect score. But if they're faced with a new question they've never seen before, even one on the same topic, then they're potentially going to be completely lost. They haven't learned the subject, they've just memorised the training data. An overfitted AI model has done exactly the same thing. It's learned the training data so perfectly that it's captured not just the genuine underlying patterns, but also the random noise, the irrelevant details, and the statistical quirks specific to that one dataset. When it's shown a new patient's data from the real world, the data won't have the exact same noise it memorised, and its performance collapses. So how does this apply to our clinical work? Understanding overfitting is probably the single most important skill for critically appraising an AI paper. It protects you from being misled by impressive sounding accuracy metrics. This gives you one crucial question to ask when you read a study. How did the researchers validate their model? A good study will always test the final model on a completely separate, held out data set, so the model has never seen this data during its training or tuning processes. Look for the performance on that test set alone. If the authors only report a sky-high accuracy on the data they used to train the model, then be extremely skeptical. If they showed that the performance on the training set was 99%, but it dropped to 70% on the unseen test data, you spotted a classic case of overfitting. And it's that unseen test data that is the key metric to actually trust in evaluations. It means the model is a memoriser, not a learner, and it's unlikely to be reliable in your practice. So that's overfitting in a nutshell. It's a tendency of a model to memorise its training data instead of learning the underlying general principles.